Alrighty, here we go. We're going to dive into lesson 7. Lesson 7 is called Comparing Numbers and Distance from Zero. Alrighty, so let's dive in. Activity number 1 is all about opposites. Let's review really quickly what an opposite is. Opposites are two numbers that are the same distance from zero. One on the left-hand side of 0 and one on the right-hand side of 0. Or if it's a vertical number line, one above 0 and one below 0. For example, -10 is on the left of 0, 10 units away from 0. And +10 is also 10 units away from 0, but this time on the right-hand side of 0 on a standard number line. So 10 and -10 are opposites, okay? So that's just a review of opposites. Now we're going to take opposites and we're going to use that when a kind of combined way with what we learned yesterday about absolute value. So let's dive in. For our first problem today, activity 7.1, we are looking at this number line here. And it says A is a rational number. Now we haven't talked about that vocabulary word a whole lot. A rational number is literally any number you can think of. Okay, it's all the numbers we use day to day to day to day. Okay, it's the whole numbers, it's the counting numbers, it's the negative numbers, it's also the fractions and the decimals and all the weirdness in between. Okay, a rational number is literally any number you can think of. Okay, so A is literally any number we can think of. Okay, choose a value for A and plot it on this number line. Now, I could literally say that A is any number. I could say that A is 5,000 if I wanted to. I would just have to make my number line match up with that. If I wanted A to be 5,000, then each of these would have to be 1,000. 1,000, 2,000, 3,000, 4,000, 5,000. Okay, let's say A is 5,000, right? Or we could simply say that A is 5. Or we could say that A is 5, 10, 15, 20, 25. Or we could say that A is 2, 4, 6, 8, 10. It literally doesn't matter. We can use any number as long as we can use the tick marks to get us there. Okay? So part 1 is done. We have now chosen A and plotted it on the number line. Based on where you plotted A, now we're going to plot -A. Or in other words, we're going to plot the opposite of A. Anytime you see a negative sign, think of the words opposite. The opposite of A. Okay? So where is -A, or where is the opposite of A? Well, if A is here, 5 units away from 0, then the opposite of A is going to be 1, 2, 3, 4, 5 units from A the other direction. So this is -A, or the opposite of A. Okay? What is the value of -A that you plotted? Well, let's go ahead and say that A is 5. If A is 5, then what's the opposite of that? It's -5. Does everybody understand how I did that? All right. Number 3. Number 3 says, if A is a rational number, Noah said, if A is a rational number, then -A will always be a negative number. Do you agree with Noah? Explain. Now, I'm tempted to agree with Noah. If A is 5, then -A, yeah, that's a negative number. If A is 7, then yeah, -A will be -7. If A is 5,000, then yeah, A will be -5,000. But does A have to be a positive number? Let's look back to our instructions. All it said was that A has to be a rational number. Could an A be a negative number and still be rational? Yes, the answer is yes. So what if A was actually here? If A is there, then what is the opposite of A? Well, it has to be the same distance from 0, so it has to be right here. So that would therefore be -A. I know that seems weird, but let me show what this is talking about. If A equals -2, we decided these are going to be negative whole numbers, right? Negative 1, negative 2, negative 3, negative 4, negative 5. If A is negative 2, I'm going to add an if there. If A equals negative 2, then the opposite of A, does that make sense? This is now negative A. Does that make sense? The opposite of negative 2 is positive 2. Let me read that one more time. If A equals negative 2, then the opposite of A is equal to positive 2. So is Noah right? Will negative A always be a negative number? No, we just proved that it can be positive. And here's how we can write that in words. If A is negative, then the opposite of A will be positive. Kind of different, huh? We usually think of variables as always being positive, but does a variable have to be a positive number? Absolutely not. Okay, so we have to remember that. All right, so that's our final answer. Okay, moving on down here to our next problem. All about a submarine. It says a submarine is at an elevation of negative 100 feet or 100 feet below sea level. Let's compare the elevations of these 4 people to that of the submarine. All right, in order to do this comparison, I'm actually going to draw a vertical number line. And I've kind of gotten in my way over here, but that's okay. I'm just going to use the space I have over here to make a vertical number line. I want to make sure I don't go off the video. Let's start way up there and go way down here so we have plenty of room. I'm going to put our sea level. I always do wavy lines for like water just because that's sea level. I'm going to label that with 0. That's our sea level. Okay. Now we have a submarine, and we were told that it was at a negative 100 or 100 feet below sea level. So I'm just going to eyeball. I don't want to count to 100. So let's just go down here a little bit and label this negative 100 feet. And that is where my submarine is. I'm going to attempt to draw a submarine. I have no idea really what these things look like. I'm just going to pretend that I do. Sure. That looks kind of like a submarine, right? I don't know. Maybe we could do, well, I don't want to make it look like a fish. Anyway, that's a good enough submarine. There's my submarine at a negative 100 feet. Okay? Now let's compare that to where Claire is. It says that Claire's elevation is greater than the elevation of the submarine. Okay, so she's higher than the submarine. She's got to be somewhere above the submarine. Okay, we know that. So her elevation is greater than the submarine. And she is farther from sea level than the submarine is. Okay, so if she's got to be above the submarine but farther away, she's got to be farther than 100 feet away. The only way to make her farther than 100 feet away is to move her up here farther than 100 feet above sea level. Does that make sense? So if this is 100 feet above sea level, I'm going to label that as a positive 100 feet. If that's the same distance, then she must be up here somewhere. And it doesn't really matter where we put her. Let's put Claire up there. Okay? So that's where Claire lives. Is she further away from sea level than the submarine is? Yes. Is her elevation greater? Yes. Okay. Andre is next. Andre's elevation is less than the elevation of the submarine, which means that his elevation must be down below the submarine. Andre is farther away from sea level. That makes sense. All right, Andre is next. Let's look at Andre's information. Andre's elevation is less than the elevation of the submarine, and Andre is farther away from sea level than the submarine. Okay, so if Andre has to be less than the submarine, his elevation, he must be below the submarine. Does that make sense that he would be farther away from sea level? Yes, if he's somewhere down here, he is farther from zero than the submarine is. So let's go ahead and put Andre right down here, somewhere below the submarine. Okay, that's where Andre can live. All right, now we're done with Claire and Andre. Let's move on to the next person, who I believe is Han. Yes, I'm going to try to keep this number line in view here. Now we're ready to talk about Han. All right, Han's elevation is greater than the elevation of the submarine, and Han is closer to sea level than is the submarine. Okay, so if his elevation is higher than the submarine, and he has to be closer to sea level, it makes sense that he would be somewhere in here. Now, could he also be above sea level and still be closer and above? Absolutely. So we can actually pick anywhere right around sea level and it'll obey both those rules. Let's put Han right here. It doesn't really matter where we put him as long as he's closer to sea level and above the submarine. Above the submarine, closer to sea level. Okay, so there's Han. Now we are ready to move on to Lynn. Lynn's elevation is the same distance away from sea level as the submarine. Okay, so if the submarine is negative 100 feet away, or 100 feet away on the negative side, then Lynn must be 100 feet away on the positive side. There she is, Lynn. I forgot to erase her name earlier. Lynn is at 100 feet above sea level because the submarine is 100 feet below sea level. So that's where Lynn lives. Done with Lynn. Awesome. Let's move on to number 1 now. Number 1 says to write a possible elevation for each person. Okay, so there's our possible elevation for each person column. Okay, in the next column, we're going to use less than, greater than, or equal to symbols to compare the elevation of that person to that of the submarine. Okay, so we'll look at that. We're going to also use absolute value. Remember those straight bars? We're going to use absolute value symbols to tell how far away the person is from sea level. So that's the distance. Okay. All right. Let's take a look at what's already been done for us. Looks like they did Claire for us. Is it possible that Claire is 150 feet as her elevation? Yeah, because she has to be higher than 100 feet. So that makes sense. Claire can be at 150 feet. 150 feet is greater than the submarine at negative 100 feet. So there's a good inequality that they wrote. The absolute value of 150, or the distance away from zero that is 150, is 150 feet. Okay, so that's how we're going to fill out this table. Let's do Andre next. What is a possible elevation for Andre? Well, we know he's down here below the submarine and below sea level, so we know he's at a negative elevation. So what elevation could he be at? Well, we get to pick. It literally can be anywhere. Let's say he's at 186 feet. You can pick your own number. I just made that one up. As long as it's more than 100 feet below sea level, it really doesn't matter what we pick. So now to compare with the submarine, negative 186 is less than negative 100. Okay, now distance. The distance that negative 186 is from zero is 186 feet. Okay, now Han. Han, we put Claire up here. What's a possible elevation for him? Well, he's higher than negative 100 feet. On our graph, we still put him under sea level, so he's going to be negative in our example. Maybe you put him up here, and maybe yours isn't negative, but that's okay, as long as it's closer to sea level. So what's a number closer to sea level? Let's say negative, 15 feet. That would work. Negative 15 is greater than negative 100. Again, we're comparing to the subway every time. Negative 15 is above negative 100, so it is greater than. The absolute value of negative 15, or in other words, the distance that negative 15 is from 0, is 15 feet. Okay, now we're ready for Lynn. Lynn, her possible elevation, well, was there any doubt on where Lynn had to be? She had to be exactly the same amount of feet or elevation as the submarine, but above ground, right? So she has to be at 100 feet. 100 feet is greater than negative 100. The absolute value of 100 feet equals 100 feet. Okay, so now we have filled out that table. Very, very good. Moving on to number 2. Priya says her elevation is less than the submarine's and that she is closer. Okay, so she's less than the submarines and she's closer to sea level. Is this possible? Let's look here. She has to be less than the submarine, so she has to be lower, somewhere down here by Andre, but closer to sea level. Well, is that possible? If she's less than the submarine, that actually forces her to be farther away, doesn't it? So I don't think that's possible. There's no way to obey both those rules. So I'm going to say no. If her elevation is less than the sub, then she has to be further away from sea level. There's no way around that. Okay, good. Done with number 2. Well done, well done. Moving on to activity number 3. Now, activity number 3, you're supposed to do this with a partner. I would love it if you would find somebody to do this with, because this is kind of fun to make sure we really do understand less than, equal to, and greater than symbols and absolute value symbols, and just the ideas of negative versus positive numbers. This is a really great activity. I'm going to go ahead and do this as if I'm both partners, but I would love it if you would find somebody to do this with, maybe a parent or an older sibling, somebody that can help you out. All right, it says, here are some numbers and inequality symbols. Work with your partner to write true comparison statements. We're going to write true inequality statements using our symbols. One partner should select 2 numbers and 1 comparison symbol to use them to write a true statement using symbols. Okay, so our first statement has to be using symbols. The other partner should write a sentence in words, okay, that with the same meaning. Okay, so we're going to do 2 things here. We're going to write a statement using symbols, and then we're going to write a sentence in words that means the same thing. Okay, so I will do an example of this to show you what it's talking about. I'm just going to pick 2 numbers randomly. How about this one and that one? Okay, all right, so those are my 2 numbers, 2.5 and the absolute value of -8. Now, which of these 3 symbols will make this true? Is 2.5 less than the absolute value of -8? Is 2.5 equal to the absolute value of -8? Or is 2.5 greater than the absolute value of -8? Well, before I can decide this, I need to solve this absolute value, don't I? I need to decide, what does the absolute value of -8 actually equal? It actually equals 8, doesn't it? Is 2.5 less than 8? 2.5 equal to 8 or 2.5 greater than 8? The answer is less than. Okay, 2.5 is less than the absolute value of -8 because that equals +8. Okay, now I need to write words that describe this. So I'm going to write 2.5 is less than the absolute value of -8. Okay, so there is one example of something you can do for this activity. I want you now to go and do 2 more at least on your own. If not, work with a partner and match up every single one of them to one of these statements. We already used this one, right? There's my less than statement, but I want you to find at least a pair for the other 3. I think you can do that, okay? Oh, and here's a great example. So here's another example that you can follow. 4 is less than 8. In other words, you write 4 is less than 8, just like they did. Switch roles. One person does one job, the other person does the other job, and then you switch. Okay? So that's your job for activity number 3. And that is the end of our lesson. Once again, we've got an optional challenge problem here. I would love to see you try that. It is a fun one. The only thing left in this lesson is our lesson summary. Make sure you read through that so that you're sure to understand everything that you need to get out of this lesson. And now we are ready for the practice problems. But you know what to do first. Go do those yourself first. And of course, I know you'll do it.
Do your best because you deserve your best.
All right, I hope you've already finished your homework problems. Let's go ahead and grade them. We are on lesson 7's practice problems. Let's go through them. Number 1, in the context of elevation, what would the absolute value of -7 feet mean? Well, remember, absolute value means distance from 0. So this would mean the distance that -7 is from 0. That's what that would mean. The distance that -7 is from 0. Now the answer is 7 feet. How far away is -7 from 0? It is 7 feet. Okay. Number 2 is matching. Now we're not going to draw lines. We don't draw lines. We are going to write these numbers next to each of the parts, okay? Part A. The number -4 is a distance of 4 units away from 0 on the number line. Well, anytime I see a distance away from 0, I'm thinking absolute value. So -4, the absolute value of -4 is 4. We're looking for that over here. Do we see it? The absolute value of -4, or the distance that this number is from 0, is 4. I see it right here. The absolute value of -4 equals 4. Or the distance that -4 is away from 0 is 4. 4 goes for part A. Okay? Part B. The number -63 is more than 4 units away from 0 on the number line. So there's a big hint. I need the symbol for more than. So we've already used this one. Do you see a more than? There's a more than, less than, more than, equals to more than. Okay, so we know it's going to be either 1, 3, or 5. The number -63 is more than 4 units away from 0 on the number line. So again, we're talking about units away from 0. So this is going to be the absolute value of -63 is more than 4. So the absolute value of -63 is more than 4. I think that's 1. The absolute value of -63 is more than 4 units away from 0. So I think that is 1. So I'm going to put 1 next to part B. Part C. The number 4 is greater than the number -4. So that should be pretty straightforward. The number 4 is greater than the number -4. There it is, number 5. Number 5 goes to part C. 4 is greater than -4. Part D, the numbers 4 and -4 are the same distance away from 0 on the number line. Again, distance is absolute value. So the absolute value of 4 and the absolute of -4, okay, let me say that again. The absolute value of 4 and the absolute value of -4 is the same. Oh, do we see that on here? There it is, number 6. The absolute value of 4 is equal to or the same as the absolute value of -4. They are the same distance from 0. 6 goes on part D. E, the number -63 is less than the number 4. Ooh, this should be pretty easy to find. The number 63 is less than the number 4. There it is right there. 63 is less than 4. Number 2 goes with part E. Part F, the number -63 is farther away from 0 than the number 4 on the number line. Ooh, so again, this is distance further away, okay, from 0. Well, we only have one thing left, right? Both of these are distances. 63 is further away and 4 is further on the number line, right? So I think 3 is the only thing we have left, and it does make sense. The distance that -63 is away from 0 is greater than the distance that 4 is away from 0. That makes sense. So 3 must be F. We know we didn't make any mistakes because we used them all. They all are true, and we're good to go. That's number 2. Moving on to number 3. Okay, now we get to fill in our own symbols. Our choices again are the greater than symbol, the less than symbol, and the equal to symbol. Let's make sure we write those down so we don't forget what those are. This symbol right here is greater than. This symbol is less than. And again, we know that that is the equal sign. Okay, let's look at part A. -32 compared to 15. -32 is negative, so it must be less than a positive 15. The absolute value of -30 and -32. So in other words, the distance that -32 is from 0, well, that's a positive 32 feet or inches or whatever. And the absolute value of 15. Well, how far away is 15 from 0? It's 15. So is 32 less than or greater than 15? It is greater than. 5 is compared to -5. Well, 5 is positive and -5 is negative, so positives are always greater than. Part D, absolute value again, this is distance, so the distance that 5 is from 0 is 5. The distance that -5 is from 0 is also 5. So these two are equal. Okay? Very, very good. Over to the next side. 2 compared to -17. Well, 2 is positive and -17 is negative, so 2 must be greater than. F, 2 and the absolute value of -17. Well, this changes things. This is how far away is -17 from 0? Well, it's 17 away from 0. So is 2 greater than or less than 17? Now 2 is less than the absolute value of -17. Okay? Next one. The absolute value of -27 is 27. The absolute value of -45 is 45. 27 is less than 45. The absolute value of -27, again, is positive 27. 27 is what compared to -45? So this time I don't have absolute value sign, so that just stays -45. 27 is greater than -45. So far, so good. How many of you got 100%er on all of those? I hope you did. Well done, well done. Number 4 now. My received and spent money in the following ways last month. For each example, write a signed number to represent the change in money from her perspective. So either she is gaining money, right? Or she is losing money. Losing or spending, right? Gaining or receiving. So that's how we're going to decide between positive and negative numbers. Signed numbers are either positive or negative numbers, right? All right, part A, her grandmother gave her $25 in a birthday card. So from Maya's perspective, she gained $25, didn't she? Now, we usually don't write the positive sign, so I'm just going to write that as 25. Okay? Part B, she earned $14 babysitting. Again, from Maya's perspective, she gained $14. So her answer is a positive 14. Okay? She spent $10 on a ticket to the concert. Well, if she spent $10, that means she lost $10 or she spent $10. So it is a negative 10. That's really the only way to write that, right? So there's parts A, B, and C. I bet the next ones are on the next page, and they are. Let's move on to those. Part D. She donated $3 to a local charity. Well, from Maya's perspective, she lost this money. She gave it away, right? So that's a negative 3 because she does no longer have that money, okay? She got $2 interest on money that was in her savings account. So interest is a way of earning extra money, right? So she earned or got $2 additional, so that's a positive 2. We usually write it just like that as a positive 2. Okay, so that's the end of number 4. Wow, this is going pretty fast today. Good job, good job. Number 5 now. Here are the lowest temperatures recorded in the last 2 centuries for the United States, for some United States cities. Temperatures are in degrees Fahrenheit. All right, Death Valley, California, Danbury, Connecticut, Monticello, Florida, East St. Louis, Illinois, Greenville, Georgia. All right, part A. Which of these states has the lowest record temperature? Lowest temperature, which means these are all negative temperatures. Did you notice that? So if we want the coldest or the lowest temperature, we actually want the biggest negative number, right? Because the bigger the negative number, the lower they are on the number line, and that means it's the coldest, right? So which one of these negative numbers is the biggest? Well, this one right here. So negative 45 is the lowest temperature. Which of the states has that? California. So the answer is California, or CA for short. Part B. Which state has a lower record temperature? Florida or Georgia? Okay, so now we're comparing, where's Florida? Here's Florida. We're comparing negative 2 to Georgia, which is negative 17. Okay, so if we're comparing those two, which one is lower? Well, again, if they're both negative, then the bigger negative is the lower temperature. So negative 17 belongs to Georgia. Okay, part C. Which state has a lower record temperature? Connecticut or Illinois? Okay, so now we're comparing, let's do a triangle, Connecticut to Illinois. Now we're comparing those two, negative 37 and negative 36. Well, those are really close, but which one is lower? Negative 37 is bigger, isn't it? So Connecticut has the lower temperature there. Last one, how many more degrees colder is the record temperature for Georgia than for Florida? So now again, we're looking at Georgia and Florida. How many more degrees colder is Georgia over Florida? Well, how far away is 17 from 2 on the number line? If I have to go from 2, how many would I have to count to get to 17? Well, that's 15 degrees colder. Because 17 minus 2 is 15. So there's our answers for number 5. Any 100%ers on number 5? Give me a big woo woo. Good. Number 6. Oh man, dividing decimals. This is a review. We can handle this though. One thing I want to point out, and I hope you realized this, do I have to do long division for all 4 problems? I hope you didn't waste your time doing that, because guess what? These are all the exact same numbers, just moved around a little bit, aren't they? So let's do the first one, and then we'll talk about the others. Part A here. Part A, we're going to divide 0.024 by 0.015. Now, before I can divide, I need to move this decimal point 3 spots so that it's a whole number. So 1, 2, 3. So what I'm actually dividing is 15 into 24. Oh, that's a whole lot easier, isn't it? 15 goes into 24 once, which is 15. If I subtract, I have to borrow. 14 minus 5 is 9. All right, well, 15 can't go into 9, so I'm going to have to bring a 0 down. And I do my decimal point up as well. 15 goes into 90. Do you know how many times? Happens to be 6. 15 times 6 is 90. So there's my answer for part A. My answer for part A is 1.6. Okay? Now, that was part A. Part B. Let's compare what we're doing to part B compared to part A. We are now dividing 0.24. So our dividend is exactly the same as part A, but notice what we're dividing it by. Oh, see, and I've already messed up part B. I was looking at part A when I wrote that down. Part B has a different dividend, doesn't it? 0.24 divided by 0.015. So the divisor's the same, but the dividend is different. So this time when I move this decimal point 3 times, look at that. It changed my number inside, didn't it? Now I have 15 on the outside and 240 on the inside. Now, how is that going to change my answer? Do I actually have to do all the math? Not really, because I know that the math is going to be the same, just that the decimal point moved. So this is still, 15 goes into 24 once, right? Which is still 15 with a remainder of 9, bringing the 90 down. That's a 16, which is still a 90. But now it's a 16, not a 1.6. So the answer to part B is 16. Now, part C. Let's not even have to do the math. Can we figure this out without it? Part C. My dividend is exactly the same as part A, but my divisor moved even one more decimal point. Notice that. So how is that going to change this? Well, instead of moving 3 spots like these two did, I'm only going to move it twice. Well, moving it twice instead of 3 times, we'll put it, instead of 1.6, where will it put it? It'll put it in front, won't it? So this is actually 0.16 for part C. We didn't even have to do any math for that. Last one is part D. 24 divided by 15. Now that's exactly what we ended up doing in part A, isn't it? 24 divided by 15. We don't have to do any math. We already know that answer is 1.6. Look at that. We didn't have to do anything because we noticed that we'd already done that math. So there's our 4 answers. A is 1.6, B is 16, C is 0.16, and D is 1.6. Done! We are now done with lesson 7's homework. Well done, guys. Did anybody get a 100%er? Give me a big woo woo if you did. How about a mastery of 3 out of the 5 or better? There was actually 6. Let's say 4 out of 6. Did you get a 4 out of 6 or better? That would be mastery. That's super awesome as well. Good job, good job. I hope you fixed your mistakes along the way because now you are ready to take the Check Your Understanding quiz. Make sure you go to Canvas and do that quickly. And don't forget to always
do your best because you deserve your best.